Alright, everybody, it's your boy Joe again, coming at you in 26 colors and 46 channels across the globe. How we doing, everybody out there today? Welcome to another episode of CCNA Study Lab. Today we're going to be reviewing Chapter 6. What's Chapter 6, Joe, you say? Let me get my book out here. Oh, I broke it again. It broke again. Fix. Oh, my face. There it goes. Ooh. Woo. Alrighty, everybody. Chapter 6. It's configuring basic switch management. This is gonna be a fun episode today. Fun episode today. Woo, woo, woo. Hope everybody can join me. We're gonna have some fun. Have some fun. Alright, I love this thing. Alright. Let me remove my mask. Ready? Whoa. Man, it hurts. Sometimes. Alright. So, like I said, Chapter 6, Configuring Basic Switch Management. Okay? So this chapter right here, guys, we're going to be, this chapter covers the following exam topics. Configuring and verifying IPv4 addressing and subnetting. It kind of touches on it, just for the simple fact that to utilize Telnet and SSH as to manage your switches, you need to apply an IPv4 address to the switch, so that you can actually log into that switch via the network. All right. So obviously, to log in through the console, that's physical. So that's connecting a cable to the switch and a cable to your laptop, PC, whatever you use. To connect via Telnet or via SSH, that's going to require an IPv4 address. All right, because you're managing that switch via the network. Okay, and the network works. Again, we've covered this in the fundamentals. The network works off of addressing. That addressing is IP addressing, okay? We're only doing IPv4 right now. We're not going to be getting into IPv6 until later on, all right? So what it's going to do, it's a very high level. It's going to cover an IPv4 addressing and subnetting, just for the simple fact that we're going to have to configure the switch, get into the switch. We're going to have to assign a VLAN, an IPv4 address. That way, again, we can Telnet into the switch or SSH into the switch, okay? All right, so configure and verify DHCP client and relay. Even though that's what it says, it's not going to get into the actual configuration of a DHCP server per se. What it's covering, again, high level. We're still high level, all right? What it's stating there is, if say you had a DHCP server in that network, which most of the time you are gonna have a DHCP server within your network, all right, you're not gonna be per se, statically configuring it. You're gonna be having the DHCP server configure your network devices and whatever. But so we're gonna be static. We're going to be statically assigning an IPv4, and then I'm going to have a DHCP server, then assign it via the network, and then what it's just covering is how to set that VLAN interface to allow a DHCP server to assign its IPv addressing and gateways and whatnot. So again, we're still pretty high level. Again, we're still pretty, we're not as far into this just yet. Okay. All right. Next one, configure network device for remote access using SSH. So again, near the middle of this chapter here, we're going to be getting into SSH, and then security fundamentals, configured device access control using local passwords. So this chapter, it's going to go through some of the like confusingness of setting up users and passwords and encrypted passwords, because there is a couple different ways to set up. Say you just want got my mac and cheesy over here. Just got dinner done again for the kiddos. Mac and cheese tonight. I whipped up some of my favorite tomato soup and grilled cheese sandwiches. Oh boy, I love that stuff. Nothing like tomato soup and grilled cheese sandwiches, I tell you. My mama used to make it for me when I was little. My brothers and sisters, we loved it. I still love it to this day. But yeah, so like I was saying, there is multiples of ways to configure the switch. So either you can log in just with a password, you know what I'm saying, or if you want to log in using a username and password combination. It all depends on the type of security, I guess, you want to implement within that switch, within your network, or how that security is already implemented inside of that network. Like say, you're a network technician and you just came on board onto a company, and the other, the lead network tech has a certain protocols and parameters that the devices need to fit, and you have to go in and set it. You have to set that new switch to these configurations predetermined by the network design that the network lead or engineer has already put in place for you to configure on these. So that's what chapter 6 is going to cover, is the multiple types of different security, well, at least fundamentally what the passwords and the usernames and how to configure those. It does touch on again, very high level, utilizing a AAA server to verify username and passwords. We won't, because it's still very high level, we won't lab that up just yet. I'm gonna wait to get to the AAA chapter before we start setting up that type of a server to verify usernames and passwords and whatnot. Just because setting that up, it's gonna take me a little bit of time to set that up, and I want to have that set up beforehand for you guys. And we need to really dive deep into what that is, into what that means, the reasoning for that. So again, we're staying high level, all right. And again, as these chapters progress, we're gonna start coming back down that ladder to the lower level topics, to get into the nitty gritty things. Yeah. So I hope you guys, are ready. Get your learning caps on. I got my learning cap on to cover all my baldness here. Okay. Hope you guys get some coffee. Remember, we're gonna review chapter 5 to start things off with. And if you didn't catch yesterday's stream was analyzing Ethernet LAN switching. Okay. We're gonna get back into the Pearson test exam program there, and we're gonna review chapter 5, and then we're gonna jump over to the CCNA 200-300 exam. All right. Cert guide there, and we're gonna go through chapter 6 today. All right. Then we're gonna go over and we're gonna create a lab. We're gonna jump onto the command line interface. We're gonna set up. What we'll do is exactly how this chapter has it. We'll set up. We'll get a switch. We'll get a PC up on there, so it'll just be a switch in a PC. and then we'll go through the differences between, having, the console, logging in via the console, logging in through SSH, logging in through Telnet, and then the multiple different ways with the username, no username, just password, encrypted password, so on and so forth. So you guys can have a nice, you guys can see how it is on the actual command line interface. The book does a great example, and it gives some really, really, really nice code block snippets of that example. And we're just gonna lab it up. We're gonna be using CML, Cisco Modeling Lab. I haven't verified if SSH is broken on that switch. We'll find out tonight. If it is, no big deal. We'll just fire up GNS3, and we'll use that image to configure SSH. If it's broken on Cisco Modeling Lab, no big deal. We have the means to get around it. So yeah, here we go, guys. All right, let me get to my other. Let's get to the whiteboard. You guys know how much I love my whiteboard, and I know I don't need a new marker. We're good. Switch. Let me switch my scenes. All right. Drop this down here. And come over here. And boom, baby. Woo! All right. Let's set up here. Let me grab my handy dandy markers. We're good. Got my markers. Get those in my pocket. Board cleaned up real quick. All right. Let's get started, everybody. How's everybody doing? Hope everybody's doing good out there. Hope everybody's staying safe, staying healthy. Wada, wada, wada. All right. Let's go up here. Boop. All right. Whatever. Well, again. Alrighty, chapter 5 review. We got all the 4 exams set up. All right, let's get started with the review, guys. All right, first question. What will a switch compare in its MAC address table to be able to forward a frame? Remember, we talked about this was one of the things we hit hard about. So it doesn't care about the destination. It doesn't care about IP first off. Switch logic only cares about layer 2, which is MAC address, okay? Forwarding frames, okay? And it's not going to apply the destination address to its MAC address table. It's going to apply the source MAC address. Whoa, what? Oh, I didn't read it fully. All right, we're going back to. All right, Joe, you need more coffee this morning. All right. So, but yeah. That was my bad, guys. I need more coffee. All right. All switch ports reside on VLAN 1 with no port security or static MAC address table entries defined. Host B remains power off. So host B, where are you at, host B? So host B right here. Host B remains powered off. All right. But all other hosts can ping each other successfully. Later, host B powers up and the user issues ping 10.1.1.4. So that's 10.1.1.4. There we go. Cool. Command to generate host B's first network traffic, which answer describes the frame forwarded scenario. Okay. So let's take a look at what we got for, and we need to select two answers. So the frame will be forwarded out of switch 2 gigabit 0-1's interface. The frame will be forwarded to host D. The frame will be forwarded to host A. The frame will be forwarded to switch 2, but not switch 3. All right. So host B. Later. All right. So let's think about this. So all other devices have already been so all other devices have been already fired up. So these switches should already know but everything besides host B's MAC address, okay? But all these switches should already know host D, all right? And it's host B is pinging host D. So the frame will be forwarded out gigabit. No, because it's not going to be broadcasting it because it already knows the destination MAC address and where that resides out of. All right. Frame will not be forwarded to host A, so it won't be that. So it won't be forwarded to host A, and the frame will be forwarded to S2 but not S3. All right, we're gonna go with that. All right, let's read this now. In this scenario, because the recent boot, host B begins an empty ARP table. Yep, I get that. As a result, host B needs to send an ARP request also in the ARP broadcast frame. So the question about the following ARP request. Issues B, command that generates this first network traffic. But see, it should have specified the ARP. It's specifying the ping. As a result, all three switches. Yeah, I get if that was ARP, but it's saying that it's pinging it. Yeah, see how sometimes these questions can get you? The answer claims that the frame will be forwarded. Correct. A LAN broadcast will be forwarded to the host, including host D. The answer. Yeah, see, that makes sense. Again, that makes sense if the question had specified ARP. Okay. Yeah. Once host B turns on, it's going to send out an ARP broadcast to all the switches and devices. It's going to send that ARP request to all of it. Yeah. See, with it saying ping, that's what got me. It's already, so, whatever. I'll accept my defeat on that one. All right. What is the default aging time for a MAC address table entries that have not been used? Default, I want to say 300 seconds. Yep, okay. In the figure, all devices are statically configured with IP addressing, mask, and default gateway information, assuming that all switches have learned the MAC addresses of all devices in the figure. PC1 pings PC4, and PC1 receives the reply confirming that the ping worked. Which of the following are true about the frame sent in this network and their encapsulated packets? Okay, so let's do some little drawing. So PC1 pings PC4. PC1 pings PC4. Okay, and PC1 receives a reply. So then it replies back, cool. Confirming that the ping worked. Which of the following is true about the frame sent in the network and their encapsulated data? Consider the frame, consider the header frame encapsulation. Okay. Let's think about this, and we have to choose two answers. So remember that when, let me crack my window, get these lights, get so hot in here. Remember when the frame passes through when it hits this router, it's going to de-encapsulate it. And it's going to strip off that MAC address. All right, it's going to strip off the destination MAC, and it's going to add its own MAC address as the source. All right, but it's going to continue. It's going to still use the source IP. So the frame that contains the ICP echo reply sent to PC4 has the destination MAC. No. All right. The frame that continues sent by PC4 has the destination MAC address of PC1's MAC. No, because it's gonna have the routers. Okay. The frame. Oh, got some people in chat. What's up, Bumbo? How we doing, brother? Yeah, man, I biffed it on that other I biffed it on that last one. Just because when it said ping, when it was mentioning, I'm thinking of what we covered in that last chapter. And, you know, when it said ping, I got a little, I guess, the question could have been rephrased better. Kind of got me off guard. Whatever. The frame that contains the ICP echo sent by PC1 has the destination MAC address of, yes. Yes. So the frame's going to have, since the frame goes through here, remember when it gets de-encapsulated and then encapsulated again, it's going to have now the router 1's destination MAC on it, okay? All right, let's move on. The frame continues. The frame contains the ICP echo request sent by PC1 has destination MAC of destination MAC. No, it's going to have destination MAC of the actual router. All right. The frame that contains the ICP echo reply sent by PC4 has destination MAC address of the. Let me erase this one. Frame contains the PC1 has the destination MAC. No, it's gonna have the destination MAC of 50501. So the destination contained by the ICP destination. Yes. So this one's right. Then the frame contains the ICP echo request sent by PC1 has the destination IP of 10. What's the IP address of that one? Yeah. No. All right. Don't select that one. All right. So it has. Remember, so on the frame on that packet, it's going to have the destination of the actual PC, but it's going to have the destination MAC as a router 1. What the? Flaming hotcakes? The frame that contains the ICP echo reply sent by PC4 has destination MAC of the 50. Let's read this explanation real quick. So the IP header shows that the Ethernet header includes the source MAC of PC1 destination. The Ethernet frame after the router has the packet, including the de-encapsulation of 501. I guess. See, what I assumed was since that frame's leaving 501, going to that, it's going to have that destination MAC. But what it's stating is when it's going to pick up 500's MAC and use that as the destination. Okay. So Yeah, I'll accept that. Doing real rough on this one. We're gonna have to do this one all over again. All right. After power on, a frame arrives at the switch. The switch had not yet learned the source MAC address of that frame. Which action must the switch take in this case? So after power on, a frame arrives at the switch. The switch had not yet learned the source MAC address of that frame. All right. Switch. So the switch adds the source and destination of that MAC to the MAC address table. No. The switch adds the destination. Nope. Switch adds the source. Switch adds the source. All right. Which type of memory does the switch use to build the MAC address table? All right. So that's the TCAN. How does a switch build its MAC address table? By listening to incoming frames and examining the source MAC address? Pretty much yes. By listening to incoming frames and examining destination? Nope. By listening to outgoing frames and examining the destination? Nope. Nope. So it's by listening to incoming frames and examining the source MAC address. All right. All IP addresses are configured for the PC, and they are correctly connected to the network. The MAC address table on the switch looks like this. Cool. All right. PC4 has a layer 2 address. PC3, yep, all fours. In its ARC table, PC4 sends a unicast ping request to PC3 as shown in the packet. So here's the packet capture. The output comes from the network analyzer. Yep. For each PDU. All right. What will be the result of the ping? All right. The switch will filter the frame and not forward it. All IP addresses configured for the PC, and they are correctly connected to the network. The MAC address table is switch. Yes. Okay. PC4 has a layer 2 address of PC3 in its ARC table. The PC sends a unicast ping request to PC shown in the packet. What will the destination? It's the IP. All right, so let me grab my little handy dandy marker. So that's the source. That's the dash. And let's move on a little bit. Now let's just see what this question's asking. The switch will be filtered out the frame but not forwarded. The switch will relay them echo request with the echo reply. The switch will flood the frame to PC3. The switch will flood the frame. I'm pretty sure the switch, yeah, because these are obviously it's split up in VLANs. So the switch will apply because it's not PC4 is just trying to ping PC3, which they're both in the same VLAN. All right, let's go with that one. It floods the frame. Oh, I get the question because it hasn't learned. It has, yeah. All right. So this is where I jacked up this one. So it hasn't learned PC4's actual MAC address. So the MAC address is not in there. Yeah. Absolutely. So it hasn't learned the MAC address. The MAC address for PC4 is not in the MAC MAC address table on the switch yet. So it's gonna flood it out. But it ain't gonna flood it out because since it's depicting VLANs, it's not gonna flood it out those VLANs because that's a total whole other network. But it will flood it just the PC3 because that's the only thing that's connected to that network. So, all right, cool. This is why we do these chapter reviews. I needed to redo. Yeah, I did pretty bad on this one. All right, let's start a new exam. Hopefully it gives me some different questions. Let's select it again. Chapter 5. Let's do it again. All right. What will the switch compare in its MAC address table to be able to forward a frame? This man, I hate that fact that it asks us the same questions all over again. So yeah, destination. Yeah, that's what I biffed it last time. All right, how will the switch build its MAC address table? By listening to incoming frames and examining the source. All right. After power on, a frame arrives at the switch. The switch had not learned the source MAC address of the frame. Which of the actions will it do? The switch adds the source and destination. No, switch adds the destination. Switch adds the source. All right. And this one I got wrong last time. So PC1 pings PC4. What happened? So this is where I biffed it with when that frame comes through this router, it's going to pick up at 500 as it's leaving, not 501's MAC address. So that's the logic I messed up last time. I assumed that since it's leaving out 501, that it's going to pick up 501's MAC address, not 500's MAC address. So my logic is I confused that up. So when PC4 replies back, instead of it picking up 500, it's picking up 501's. All right. So the frame contains the ICMP echo sent by PC1 with the destination IP address. Yeah. The frame contains the ICMP echo sent by PC, and it has the 50. The frame contains the ICMP sent by the reply has the destination MAC. Nope. That's what I got wrong, because when it sends it out here, it has 501, but when it comes from PC1, it goes that way. All right. So, all right. All switch ports reside on VLAN 1 with no port security, nor static MAC address tables. Entries defined with no port securities. Host PT remains off, but all other hosts can ping each other successfully. Later host B powers on, issues the ping 10 dot. Yep. And so this is exactly where I got confused. This is where I guess. Hold on, real quick. My monkeys are going crazy. Hold on. Crazy monkeys. Losing their minds. All right. So, yep. So what we're gonna do. So when host B pings host D, this goes back to ARP. This is where I got confused the first time, because I was thinking that ARP already had done its job. But the question, I'm almost. All right. So it's going to forward it to, the frame will be forwarded out. Yep, because now it's going to flood everything. The forwarded to host D. Yep. All right. So it's going to flood it out it's going to flood it to everywhere besides the actual source. All right. What is the default aging time? So this is 300 seconds. Let's TCAM. And then this was that last one. Again, because it's separating by VLAN here, it's going to flood it to it's gonna flood it to PC3. Cool beans. All right, there's our little review. Just wanted to just touch that real quick one more time. All right, let's jump into chapter 6 here. Grab some water real quick. All right, chapter 6, configuring basic switch management. Configure and verify IPv4 addressing and subnetting. Configure and verify DHCP client relay. Configure network devices for remote accessing using SSH. Configuring device access control using local passwords. All right, let's give it a little overview. The work performed by network devices can be divided into 3 broad categories. The first and most obvious, called the data plane, is the work of the switch. Let me draw a switch real quick. Kind of give us a little. I'll do some layers. All right. So the data plane, we'll do the data plane as the low level because it's doing a lot of the low level stuff. All right. So the data plane is the work that the switch does to forward frames generated by the devices connected to the switch. In other words, the data plane is its main purpose of the switch. Second is the control plane. Control plane. All right. Control plane refers to the configuration and process that control and change the choices made by the switch data plane. The network engineer can control which interfaces are enabled and disabled. Which ports run at which speeds, how spanning tree blocks some ports and prevents loops, and so on. The third category, the management plane. All right. The third category, the management plane. In this topic of this chapter, the management plane deals with managing the devices itself rather than controlling what the device is doing. And this, in particularly, this chapter looks at the most basic management feature that can be configured in a Cisco switch. The first section of the chapter works through the configuration of different kinds of log security. The second section shows how to configure IPv4 settings on the switch so it can be remotely managed. The last short section then explains a few particular matters that may make life easier when live. So, on network devices, routers, switches, and whatnot that have at least an operating system, all right, you're dealing with 3 planes. You have your management, high level, control, then data. All right, and how this kind of works is, so the data, we're thinking data low level. So that's dealing with the actual frames. It's dealing with all that information that's coming in and out, passing through that device there, that switch there, right? The control plane is telling the data plane what to do with all that information. So the control plane tells the data plane, all right, so you're gonna be sending information out the FAR0, the FAR01 port, or the gigabit 0- whatever port. Okay, so the control plane is what's telling the data plane what to do with all that information, but the data plane is what's handling all that information. Okay, the management plane, high level now, is what you, the network engineer, all right, here's my little network engineer here. You, the network engineer, you're typing in all the configurations, all right, into the management plane, which the management plane is then relaying, is taking all that information, filtering that down to the control plane, which the control plane is taking that information again and then using that to manage the data plane. So I hope that kind of made sense, where you're the one doing all the, so on the command line interface, you're punching in, you're switching all the configurations. The control plane is taking those configurations and now it's controlling the data plane. And the data plane is the one that's handling all that, processing all that data that's coming through that that device, the switch, the router, whatever that device may be. Okay, as long as you have that device has an operating system, an OS in it. Okay, because if it doesn't have an operating system in it, obviously there won't be a management plane. All right, it'll just be primarily, I believe, with devices that have no operating system. Obviously you still have your data plane because it's like a hub. It's just going to be processing and sending data out of, just straight data out of its ports there. All right, so that's kind of how that breaks down. All right, but again, that's not what this chapter is. This chapter is going to be going into passwords and security and stuff like that. It's going to be touching on that stuff. All right, let's do the do I know this quiz already. Here's some more of those highlights, those stinking highlights from whenever ago. Let's delete them real quick so we don't get confused by them. All right. Imagine that you have configured the enable secret command, followed by the enable password command from the console. You log out of the switch and log back into the console. Which command defines the password that you have to enter to access privilege mode? Okay, so you log into the switch and log back out. Which command defines the password to access the privilege mode? Now, the enable password command, from the console perspective, that will get you into the user mode. Okay? Not any further. And if you enable the enable secret, you've actually added 2 layers of security to get to the next level, pretty much, the privilege mode. So, which command defines the password that you have entered to get to privilege mode? So that will be enable secret, okay? So do 1, B. All right. An engineer wants to set up a simple password protection with no username for some switches in the lab. For purposes of keeping curious coworkers from logging into the lab switches from their desktop PC, which of the following commands would be a useful part of that configuration? So what is he trying to do? He wants to set up a simple password with no username. Okay. So what do we got? We got login VTY, we got login password, login local, and transport SSH. So he's not mentioning anything about SSH. Login local, when you put login local in the VTY subcommand, that's actually going to be looking for a username. So it's not that. A password console command. So I'm going to go with actually A on 2. See what we're right. Let's keep it moving. An engineer had formerly configured a Cisco 2960 switch to allow telnet access so that the switch expect a password of my password from the telnet user. Beautiful telnet. The engineer can change. The engineer then changed the configuration to support secure shell. Ooh, he came to his senses. Which of the following command could have been part of the new configuration? All right. An engineer formerly configured a 2960 switch to allow telnet access. Yeah. That. The engineer then changed the configuration to support secure shell. Which command could have been part of that new configuration? So we have, choose two answers. Okay, so transport SSH. Now, the question doesn't mention that he's getting rid of Telnet or enabling in Telnet. But he wants to make it configured for SSH. So username enables secret and login local. Ooh, but we gotta look at this. We got global configuration. All right, let's go with B and C. Let's go with B and C. B and C. All right. Get out of there, you stinking highlight. All right. An engineer's desktop PC connects to the switch at the main site. A router at the main site connects to each branch office through a serial link with one small router and a switch at each branch. Which of the following command must be configured on the branch office switches in the listed configuration mode to allow the engineer to telnet to the branch office switch and supply the password and login? Choose 3. All right. So we need an IP address, we need a default gateway, and obviously we need a password. So the IP address on the interface configuration mode, yeah, because you need to be on the VLAN interface mode to assign an IP address to that. It's not a global. You can't assign an IP address in the global configuration mode because it doesn't assign it. You're not going to be able to assign it to a particular VLAN. So 4, we're going to go ahead with A, because you have to do it to an interface VLAN. All right. The default gateway command so again, you have to be in VLAN configuration mode to, again, let's take that back. Let me take a couple steps back. Hold on. The IP default gateway. So, and that would be actually D. Because so in global configuration mode, you can assign a default gateway, so that way all the supporting VLANs can use that default gateway. All right. Let's move down. The password command in the console configuration mode. The password command in VTY configuration mode. Password command in VTY. Yeah, so it'll be F. All right. Move down to question 5. A layer 2 switch configuration places all its physical ports in VLAN 2. The IP addressing plan shows that the address 172.16.2.205 with mask 255.255.255.0 is reserved for use by the new VLAN and VLAN switch, and that 172.16.2.254 is already configured on the router connected to that same VLAN. The switch needs to support SSH connections into the switch from any subnet in the network. Which of the following commands are part of required configuration in that case? All right. A, the IP address 172.16.250 command. No, it's assigning it to VLAN 2, not VLAN 1, VLAN 2. How many do we have to choose? We have to choose 2. The IP address of 172.16.2.250. Yeah, so we're going to say 5. We're going to say B real quick. And the IP gateway of 172.16.2.254. in the global configuration mode. Yep. And no, so D is wrong anyways. So we're just gonna go with C. All right. Which, oh, don't scroll all the way down. Which of the following line subcommands tell the switch to wait until a show command output has completed before displaying a log on the screen? So log IP domain name lookup. So that'll prevent, so again, that like, so if you're on the command line interface and by accident you misspell something, you press enter, the switch or the network device thinks you're trying to reach out to something. So it's going to look up, it's going to try to look up those addresses through DNS. So by using this command, you're shutting that down. All right, exec timeout, different history size. So that's just telling you that. So it's going to be process of elimination, log synchronously. All right, and what that's doing is it's pretty much, it's going to wait for you to process your command before it starts spitting out any log messages. Because if you don't put that, what's going to happen is as you're going through your configurations, say you went into VLAN 1, interface VLAN 1, and you type in IP, and then you start going for address to do IP address, yada yada yada. What's going to happen is all of a sudden that interface, that VLAN interface is going to come up. So it's going to come up, and then it's going to start showing messages that interface has come up, and what it's going to do is that message is going to come, and it's going to pretty much, as you're entering that, it's just going to remove. It's not going to remove it because you can just tab down and you can continue on what you're doing. But what this is stating is log synchronous will prevent that. So you can finish your command and then that message will show up after you're done doing that. So that's what log synchronous does. We'll go with A. All right, you guys can already tell. I believe we got most right. So B, A, B, C, A, D, F, B, C, A. Cool. All right. Wet my whistle real quick before we jump into it. All right, securing the switch command line interface. By default, a Cisco catalyst switch allows anyone to connect to the console port. We talked about that yesterday. We're pretty much by default. It's pretty much stating as if you can get into the wiring closet and you can physically get to the switch, by default, Cisco says, hey, whatever, you can have my switch. You can have the switch. So by default, it doesn't have a password. It doesn't require a password to be set via the console port. Okay. Access user mode and to move in. So you can pretty much put your little console, log in right to the console, and you can move from user mode, all the way to configuration mode. All right. However, everyone needs to operate the switch remotely, and the first step to process is to secure the switch so that only the appropriate users can access the command line interface. So by default, though, you can't just remotely access the switch remotely. Couple of things. You haven't assigned an IP address to the whatever VLAN you're going to be using as your management VLAN, or so on and so forth. So the first topic of the chapter examines how to configure login security for a Cisco Catalyst switch. Securing the command line interface includes protecting access to enable mode, because from enable mode, an attacker could reload the switch or change the configurations. Protecting user mode is also important because attackers can see the status of the switch, learn about the network, and find new ways to attack the network. So you kind of want to secure both, and that's what we're going to be covering. All right. Note that all remote access and management protocols require the switch that the switch IP configuration to be complete and working. The switch's IPv4 configuration has nothing to do with how the layer 2 switch forwards Ethernet frames, as discussed in Chapter 5, instead to support as Telnet and SSH. So again, it has, even though you're going to be assigning it, we're going to be assigning in a IPv4 address to a VLAN, it doesn't affect how the logic of the switch is working when it's forwarding MAC addresses, okay? All right. This is a switch. The switch needs to be configured with an IP address. This chapter shows how to configure the switch IPv4 settings in upcoming sections. Okay. In particularly, this section covers the following log security topics: securing user mode and privilege mode with a simple password, so without a username. Securing user mode access with a local username. Securing user mode access with external with an external authentication server, so that's the AAA server. Again, this chapter is gonna talk about it, but we won't get into configuring a AAA server until we get to the AAA server chapter there, because I want to go through the configuration of the AAA server and how that works in your network to verify, usernames, password combinations, and so on and so forth. Okay, so again, it's going to touch it. It's going to touch on it at the very high level, but we won't get into really labbing that till we get to that portion of the book here. All right, securing remote access via secure cell SSH. Okay. Securing user mode and privilege mode with a simple password. By default, Cisco Catalyst switches allow full access from the console. But no access via Telnet and SSH. So again, you can just plug right into it. Wham, bam, thank you, ma'am. All right, but you cannot access it remotely via Telnet and SSH. All right, using default settings, a console user can move into user mode, then privilege mode with no required password. However, default settings prevent remote users from using it, obviously. All right. The default works great for a brand new switch, but in production, you will want to secure access through the console, as well as enable remote login via Telnet or SSH. You don't want to do it Telnet, but it's going to cover it anyways. So you can sit back at your desk, log into all the switches in your local area network. Keep in mind, however, that you should not open the switch just for anyone to log in and change the configuration. Some type of secure login should be used. Okay. So most people use simple shared passwords for labs. The preferred, so some of the methods used is only password only, not using a username. And we're gonna go through both of those. All right. So it's just stating different passwords for Telnet versus VTY line. So this would be Telnet or SSH right here. Woo, that's awful. So this is just representing Telnet and SSH. This is console. So physically going through the cable. All right, this is over the actual network. All right, and then there's, you can set a console password, and then you can set a VTY password as well. So you can log in remotely using two different passwords, or you can set it up with the same. And then the enable password, this will be the enable when it gets into the enable secret here. All right. Let's move down. Let's read the note real quick. This section refers to several passwords as shared passwords. Users share these passwords in that all users must know and use the same passwords. In other words, each user does not have a unique password / username / password to use, but rather all the appropriate staff knows and uses the same password. So it's just stating that probably within a simple network, the network engineer has set it up where there's a shared password to log remotely into these devices, and not per se you're going to be using your quote unquote personal username / password combination. That gets into the realm of when we get to the AAA server side, where it matches those key pairs up for the extra layer of security from there. So that's covered in later chapters. All right. In addition, Cisco switches protect enable mode, also called privilege mode, with yet another shared password called the enable password. From the perspective of the network engineer connecting to the command line interface of the switch, once in user mode, the user types enable exec command. This command prompts the user for an enable password. Okay. If the user types the correct password, the iOS moves the user from user mode to enable mode. Cool. All right. Example 6.1 shows an example of the user experience of logging into a switch from the console when the shared password and shared enable mode passwords have both been set. Note that before this example begins, the user started the terminal emulator, physical connected with the physical connection on the laptop and console cable. So he's physically connected via the console. So the network user, Bob over here, is on his little PC over here. All right, here's our little switch. He's physically connected, all right, to the console port. All right, he's got his terminal emulator, which most likely is PuTTY. You know, he puts in the 9600, 8 and 1. There we go. And he's prompt with the first password, whatever faith. All right, and then he's in user mode, and then he moves into enable mode. All right, and he's prompt for another password, which is where they have it as love. All right, so because he moved into user mode, he was prompt for a password, which was faith, and then he wants to go in enable mode. Okay, getting to the next level of security, he's prompt for another password, which they have it as love. Okay. All right. Note that the example shows the password text as if it's typed faith and love, along with the enable command that moves the user from user mode to enable mode. In reality, the switch, yeah. So remember how I said on the command line interface, this portion, even when you're typing, you're not going to be able to see. It ain't going to show you clear text. Now, if you're hooking up through Telnet, it's going to show clear text no matter what. Well, through the wire it will. But on the command line interface, you're not actually going to see that as clear text. It's just going to be nothing. It's just going to be blank. But it actually is registering what you're typing into that. So don't get nervous. All right. All right. To configure the shared password from the console telnet and for enable mode, you need to configure several commands. However, the parameters of the commands can be pretty intuitive. Configure 6.2 shows the configuration of the 3 steps. So it's going into we're already in global configuration mode or configuration mode. So from global configuration mode, we're going to enter the command line console 0. That's going to bring us into the console subcommand. Okay, we're going to enter login. All right, now we're not going to log in. There's login local, which we're going to cover after. Login is pretty much just stating we're just going to be logging in with the password. All right, and we're gonna issue the next command, which is password, and we're going to be giving it the command faith. That's just what we're setting as our password. That could be whatever else you want it to be. You know, McLovins, chicken nuggets, Tatooine, whatever you want it to be. All right. Now you're gonna exit out of that subcommand, the console subcommand interface. Okay. You're gonna go back to global configuration mode, and then you're gonna enter line VTY 0 space 15. Now that's gonna bring you to the line VTY subcommand interface, and you're going to repeat that same thing. You're going to issue the command login. Again, a login is just registering that you want to set it up just for a password. All right, you're not going to be setting up for password and username combination. Okay, and then password, you're going to enter the command password, and then hope right here. Again, that's just what you make it as your actual password. You can put that, again, whatever you want it to be. All right, so again, simple password security configuration, this configuration for these three. The configuration for, and I didn't cover this right here, so. And then you're going to back totally out of line console and VTY mode. You're going to be back in global configuration mode. And then that's when you're going to prompt it for the enable secret. So enable secret is the actual command. Love right here, that's just what you make it to be. Now that, when you set that, again, you're setting it so once you log in, either console or VTY, you can get to user mode. All right, now to get to enable mode, you're going to be prompted for the secret, the enable secret password, okay? And that would be love as it's depicted here. All right. All right. Password value. Yep. Login tells the iOS to enable the use of a simple shared password with no username. No username. All right. All right. On this console line, so that the switch asks the user just for the password. Remember, just password. It's just looking for a password, not username password combination. All right. To configure enable password shown on the right of the figure applies to all users. All right, no matter whether they're connected via console or telnet SSH. The command to configure enable password is in global. Remember, global configuration mode. And then the command is enable secret. Enable secret is the actual command, and then the password value. And you set the password value as whatever you want it to be set at. All right. All right. Older iOS versions use the command enable password. Password value. I just seen something come up on the thing. All right. On older iOS versions, use the command enable password value to set enable password, and the command still exists. However, the enable secret command is much secure. So this still exists, all right, but it's going to be clear text on when we'll do the show run, and that will still come up as clear text in that show run command, all right. But the enable secret is a much more secure. So when you in global configuration mode, again, when you pass the command enable secret, that's going to encrypt that password for users, when they're running the show command. Like, say for instance, you set and this is the reason why. So say for instance, you set the console, somehow a bad actor found out the telnet password, and they logged into the switch. They can run, say, like the show run command, and it will show them, if you just enable the enable password, it'll show them the password to then get into enable mode, because it's going to come up as clear text. All right, so that's why the enable secret command was created, because it's going to encrypt that password so nobody can just see that password as clear text. And we'll lab that up, okay, guys? All right. To help follow the process for an easier study later, use the configuration checklist before the example. The configuration checklist collects the required and options set to configure as a feature described in the book. The configuration checklist for shared password for console. So here's a little checklist that we're pretty much going to step by step this in the lab when we jump into CML. So we won't beat this up too bad right now. But here is here's a nice little checklist right here. Again, we're gonna lab this up, so we're not gonna spend too much time talking about this. All right, and here's so this is what you're gonna see. So this is on the command line interface. This is what you're gonna see right here as you're passing all that information through to your devices. So here we are. So we're in enable mode. All right. Configure. We're going to move into configuration terminal mode, which is going to bring us to global configuration mode. All right. We're going to enable secret love. Okay. We're going to move. All right. We're going to exit back out. All right. We're going to go into the line console mode. All right. Now it's going to bring us to the line console subcommand interface. Okay. We're going to issue these commands. Okay. We're going to exit back out, back to global configuration mode. And now we're going to move into line BTY mode, live BTY subcommand interface mode. Okay. And then we're going to do this pretty much the same process in there to then enable SSH. Now, we still won't be able to remotely access this device yet, even though we've set the parameters for, say, SSH, okay, or Telnet. We're not going to be able to remotely access this device until we configure an IP address on our management VLAN, okay? Which we're just going to be using VLAN 1 for this instance, just to keep things kind of simple, okay? All right. Yep. So here they're just going to be running the show run config. All right. And this is again. So here's the show run. Like I said. Now, if we had just used the enable password command in global configuration mode to set a password, so to move into global configuration mode, it would come up right here as clear text. Okay, it would enable, and then it would just show you in clear text the actual password. All right, so then even if the user who was able to get into user mode doesn't know the enable password, by running the show command, they would be able to get into that next level. Okay. All right. And here you're going to see, it's just going to be showing clear text. All right. For those right there. All right. All right. For historical reason, the output of the show command in the last 6 lines. All right. It just separates the 0 through 4 and the rest of the 5 through. It's just separating the VTY lines. It's just historic. That's an old thing right there. That's all it's stating. And that's why you see this right here, 0 to 4 and 5 to 15, okay? So don't get hung up on that, okay? All right. Cisco switches support 2 other login security methods that both use per username password instead of shared password with no username. One method referred to as the local username and password. Configure the user / password pair combinations locally. That is the switch's configurations. Switches support the user. This support the local user password username key pair for console, telnet, SSH. But does not replace the enable password. So it's just stating, even though we've added the user password key combination, it does not still replace, all right, the enable password, all right. So you still need to use the enable password to move into enable mode, okay? So again, the user when we're going to set the username and password key combinations, again, we're just going to be able to get back into user mode, but we still need to know the enable secret password so we can move again into the next stage, okay? The next configuration mode, which is global configuration mode, okay? All right. Working through the configurations in the first, to the figure first, the switch, of course, needs to list the key pairs. To create these, repeatedly use the username names. Username is the command, and then your whatever name you want to assign it. Then secret sets the password, and the password is whatever you're gonna do it in global configuration mode. So we're gonna be setting up these usernames and secret password key pairs inside of global configuration mode. Okay, not in the actual sub interface modes like VTY or console mode. All right. What we're going to be doing though, we have to then log into, say, the back to the console interface and the VTY interface, and that's when we give the log local command, and that's where it's going to register for these key pairs right here. Okay. To enable the type of console, simply enable the login security method with so there it is, the login local. Basically, this command means to use local list of usernames to log in. You can also use the no password command without even typing in the password to clean up any remaining password subcommands from the console or VTY mode because of these commands. So that's just stating, say you already had enabled a console password or a VTY line password, and then you created these usernames after the fact. So you created these user key pairs afterwards. The no password will clean up that single password that you created earlier. What up, Eagle Marksman? How we doing, brother? Good to see you, man. Glad you joined. Yeah, we're covering, if you haven't caught these streams before in the past, we're covering the CCNA 200-301 exam. So we're moving chapter by chapter. Again, this is very high level, and then it starts coming down to lower level stuff. And what we're doing is we're reviewing as we go. I have been looking for a network engineer for ages. I have a simple problem for you if you ain't busy. Oh, I'm busy, but if it's a quick question, I'll try to do my best. Shoot me with your quick question. I'll do my best to answer it as I'm going along here. All right. All right. So again, we're gonna. This is just stating if you want to clean up that password, you're gonna issue that no password command inside of the sub interface console mode, sub interface VTY mode. Remember, these are different interface modes that you have to go between to set up this stuff. All right. So here's another configuration checklist. Now again, we're going to be labbing this up. All right. So I'm not going to spend too much time on this checklist because we're going to lab it up, and we're going to walk through these configuration checklists together. All right. As we are actually doing it on devices. All right. All right. So here's a little code snippet from a device here. He's logging in right into user mode. Here's his login. All right. Again, you're not gonna see physically that password. All right. It's just gonna be nothingness, but it is picking up what you're doing. It is registering what you're doing. All right. All right. And then from user mode, he wants to move into enable mode now. So from user mode to enable mode, it's gonna prompt him again for another password. That's that enable password. Okay. Now he's going to move into configuration terminal mode. All right. Okay, say I have a router into another modem and I'm using it as a switch, which works fine. On the cables, why do I get one MS through the switch versus through the router? I'm just short on Ethernet ports. All right, let me read that again. Okay, so I have a router into a modem, into another modem, and I'm using as a switch, which works fine on all cables. Why do I get 20 throughout the switch versus? That's because the switch itself, the switch ports themselves have different speed ports. Yeah. So this fuzzy Moogle. Thank you very much. So you have different port speeds on that actual switch. So you got to figure out what are your port speeds on that switch versus the routers. Port speeds. All right. So you might be having, fast Ethernet on that switch versus gigabit Ethernet ports on that router, and that's where you're getting that speed difference right there. All right. Yeah. So you just have to figure out what speed you're dealing with on those ports, and that's going to tell you a lot of information on what's going on with that drop. You know what I'm saying? Good question though, and thank you, Fuzzy Mugo. All right. Solutions. Again, you got to find out more information about that particular switch. All right, in those ports, you need to know information on those ports, and that's the only way. Like, say, I'm gonna be able, or anybody else is really gonna be able to give you the correct information, because all I can do for you now is I can just assume what's going on. I can't give you a solution without having, your actual breakout of your. Say, I need to run. You need to run your information and the breakdowns and everything else, the speeds of the ports and what you're getting, to get that solution that you're looking for. Yeah, just more info. You know what I'm saying? It's better sometimes. You need to run I need to know the types of routers, the types of switches. That's all it is, my brother. But thank you for joining me, man. Again, we're gonna learn about all that stuff as we're progressing through our study here. All right. So to continue on here, securing user. Let me just wet my whistle. All right, securing user mode access with external authorization server. So this is touching on the AAA server. Now, it's going to touch on it high level, and I'm just going to touch on it high level too, because I don't want to get into the nitty gritty of that till we get to that AAA chapter. And that AAA chapter is going to be complicated. It's going to take us a while to break through it, but we're going to get through it together. All right. The end of the example points out one of the many security improvements when requiring each user. So again, when you have a AAA server, that's when you can get into the user key name pairs, okay, and be able to set up, John Larry and Bob Smith his own password and keyboard pairs, so they can log remotely into these devices. Okay. All right. However, using the username password configured directly on the switch causes some administrative headaches. For instance, every switch and router needs the configuration for all users who might need to log into that device. So if you start, all right, say you got a network and you got multiple switches, switch, router, you got X amount of all these things, and you start, you have username, password, key pairs, and you want Bob and Larry to have their own key pairs to be able to remotely manage all your devices. You, the engineer, needs to go into each and every single router, switch, device that you have in that network so that Bob and Larry can use their username keyword pairs to remotely access your devices. Now, with use of a AAA server, all right, that AAA server is going to have those username password key pairs. All right, and what's going to happen is when Bob or Larry tries to remotely access that switch or that router is going to ask that AAA server, hey, I just got some, somebody's trying to log into my, into my management plane, and here's their username and password. Can you authorize this for me? That AAA server is going to look through its database, all right, and it's going to say, okay, I have the username password key pair for Bob, and he entered the right password. All right, so let me allow access now to that device. So that's where the AAA server, Radis server, or whatever is going to. It takes a lot of that. It gets back into the mindset of we have to think bigger picture instead of small picture. Going through every single one of these devices and setting up, those keyword pairs, you might make a mistake. You might enter Bob's password wrong on, router 2 over here, and yeah, Bob can log into switch 1, router 3, and switch 10 over here, but for some reason he just can't get into switch 3. Well, maybe because as the network engineer, you might have fat fingered it and entered that wrong keyword pair. So that's where the AAA server, the Radis server, and all that. That's where that comes into play and takes that stress off of the network engineer. I heard this great story shared by a fellow guy that I get I follow a lot, and I've actually taken a couple of his classes. He worked at he gives the great story where he worked at Disney, and at Disney they had like 500 routers within Disney. And just imagine trying to set up username, password, key pairs on 500 switches or routers. Yeah, you might make a mistake. All right, so that's where those AAA servers and Radis servers have have huge value. All right. All right. Wet my whistle. All right. Cisco switches allow. All right. Allow exactly that option by using external service called authentication, authorization, and accounting. Authentication, authorization, and accounting. AAA service. We'll say that one more time. Authentication, authorization, and accounting. AAA server. These servers hold the username, password, key pairs. They typically these servers allow users to do self-service, enforce maintenance to their passwords. Many production networks use AAA servers for their switches and routers today. Okay, so that's as a say you're a network technician, and every whatever 60 to 90 days you're gonna get an email from the AAA server saying you need to update your password, change your password, so you can continue to access these devices and whatnot. All right, and that's what it states that as the AAA server, it on that plane, on that level, it adds a whole new aspect of how to do this stuff, and it's so much better. All right. The underlying login process requires some additional work on part of the switch for each user login. But once set up, the username password pairs administrative is much less. When using a AAA server for authentication, the switch or router simply sends a message to the AAA server asking whether the username password are allowed, and the AAA server replies. Figure 4.6 shows an example with the user first supplying the username password pair. The switch asks the AAA server, and then the server replies to the switch stating that the password is valid. So again, what we just wrote, you're logging in remotely to the switch. Switch then sends a message to the AAA server. Is this okay? Okay, it is. All right, now then it switches and then it sends a message back, and then you can log into your, network device. All right. Securing remote access with Secure Shell. Secure Shell, the only way to do it. Now remember, we talked about this. Telnet sends everything as clear text through the network. All right. If somebody was sniffing around your network, all right, using a program like Wireshark or something like that, if you're using Telnet, they can see everything you're pushing through that wire. All right. It's pretty funny when it comes through. All right. So far this chapter has focused on the console and Telnet, mostly ignoring SSH. Telnet has one serious disadvantage. Yeah, it does. All the data in the Telnet session flows as clear text, including the password exchange. So anyone that captures the message between the user and the switch in what is called a man-in-the-middle attack. All right. So there's our first. So now we're starting to get into, we're going to be naming out attacks. So man-in-the-middle attack. So that's me sniffing on your little network there. All right, can see the password. SSH encrypts all data transmitted between the SSH client and the server, protecting the data and password. All right, SSH uses the same. SSH can use the same local login authorization method as Telnet with the local configured username password pair. SSH cannot rely on authorization methods that do not include a username like shared password. Some configurations. So the configurations to support support local username for Telnet, as shown previous in 5.6, also enables local username password authorization for incoming SSH connections. Okay. Figure 6.5 shows one example configuration of what is required to support SSH. The figure repeats the local user configuration as shown in earlier figure 6.3, and as used for Telnet, shows 3 additional commands required to complete the configuration for SSH on the switch. Now, to enable SSH, this is one of the commands. Again, I know you guys ain't. Some of you all might be familiar with Cisco Modeling Lab. If you are, then you'll understand what I'm saying. But in the images that I have for Cisco Modeling Lab, on the router image, this command right here, the crypto key generate RSH command, is missing from that image that I have. And I've already contacted the folks over at Cisco. They're aware of it. They've sent me back an email actually thanking me for picking that up. They're in the process of, they have to go back through all those images now and figure out, what other commands might be missing. I have reached out to a couple other folks within our little community, and there's some issues with the cloud service router that's also in that same images as well. So there are some commands that are a little bit funky, and that's why I said once we get into maybe router stuff, we might jump on my GNS3 that I have, because the images that I have for GNS3, I have already confirmed that the crypto command is there and does work, and we can generate an SSH, an RSH key, a crypto key for that router. Now, I believe, though, the image that we're going to be using tonight in Cisco Modeling Lab, the switch image that we're using, I believe that we're going to be okay. So I believe we're going to be able to generate a crypto key. And so if you have any Linux, I guess, if you've used Linux, if you have any Linux skills or whatever, when you're SSHing into, say, another Linux computer or whatnot, you need to generate an SSH key pair with that other device so you can log in. All right. Now you can set parameters when you create these RSA keys. You know what I'm saying? You can set phrases, with passwords, and you can make it extremely complicated. And the reason why you're making that extremely complicated because you're adding layers and layers of security and encryption inside of that actual key. Now you can generate a key that's that a whole entire text file long. You know what I'm saying? That's because you don't want that's that layer of encryption, of security behind all that. So Joe Schmo from who knows who just can't get inside of your PC, get inside your network device, and do whatever he wants in there. All right. Adding SSH configurations to local username configurations. iOS uses 3 SSH specific configuration commands in the figure to create the SSH encryption keys. The SSH server uses the fully qualified domain name FQDN, fully qualified domain name FQN, all right, DN, of the switch as input to create the key. So you can that domain name, you can create it as Pizza Palace, whatever, or Joe Schmo, whatever, or I usually just do, cisco.example.com. I don't, you don't have, it doesn't have to be an actual real domain name. So don't get too hung up when it asks you for an IP domain name. You can simply use example.com, cisco.com, myhome.com. Don't matter. All right. So let's continue from there. All right. So on the switch creates the FQ, the fully qualified domain name from the host and the domain name of the switch. Begins with both values, just in case they are not already set. The third command, crypto key generate RSA command generates the SSH encryption key. All right. The configuration in 6.5 relies on two default settings that the figure therefore conventionally ignores. iOS runs an SSH server by default. So by default, it's running an SSH server. In addition, iOS allows SSH connections into the VTY lines by default. Okay, seeing the configuration happen in configuration mode step by step can be particularly helpful with SSH configurations. Note in particular that in this example, the crypto key command prompts the user for the key modulus. You could also add the parameter modulus value to the end of the crypto key command to add this setting on the command. So when it's going to prompt you for the modulus value, and that's pretty much the size of those bits in that RSA, that SSH key pair there. All right. The standard is 10. It can't be anything less than. It's got to tell you what it's the least value. So it's stating that the least value is 512. So he's just doubling up to 1024. I usually put 2048. It don't, just as an example. Okay. So here we are in global configuration mode on the switch. We're going to give the switch a host name S1. It's already S1. All right. IP domain name, example.com. Again, you can name it whatever.com. It just needs to have a domain name. Again, I usually just call mine lab.com, cisco.com. All right. Then you're going to put in the crypto key generate RSA command. Okay. It's going to just prompt this right here. It's going to start going through the stuff. It's going to ask you for the range of the modulus. You're going to put in what you want it to be set at, okay? And then you're going to jump. And now what this code snippet's doing is you're going to go into the line VTY sub interface command, all right? And it's showing login local. So it's, again, login local. That's asking for password and username, all right? Password and username, all right? He's going to exit. Now he's going to log in. He's going to log in as user, password. Oh, wait. All right, so he's just adding these users and passwords right here. So that's all he's doing. All right. Yeah, so don't get hung up on this. He's just adding he's now adding these users and passwords right there, all right? Again, that's going to get you, when you log in, say you log in through SSH, just like Telnet and just like Console, that's going to get you to the user mode. All right. Now your enable secret password, you still need to know your enable secret password so you can get into configuration mode. Okay. All right. Earlier I mentioned that that one useful default was that the switch defaults to support both SSH and Telnet on the VTY lines. Yep. However, because Telnet is a security risk, you could also disable Telnet to enforce a tighter security policy. For that matter, you can disable SSH support and allow. Yeah, why would you want to disable SSH support? You fool! And allow Telnet on the VTY lines. Seems kind of weird to me that GNS. Give me some more context-sensitive help there, Raiden. Yeah, just give me some context-sensitive help behind your comment, my good friend, and I'll do my best to answer it as we go along here. All right. So what it's stating: sig stop command. Sig stop command. Control C, kill command, Control D. End of transmission. Are you talking up here? Oh, yeah, don't get hung up. So, Control Z. So, Control Z is just exits you out. Ends of transmission. Yeah, so it's different. So this is on Cisco iOS, not Linux. So this is on Cisco iOS. So this is a code snippet from a Cisco iOS switch, not a Linux. Trust me, I completely understand. I get, well, how's this? I get your comment. So Linux operating system, totally different than Cisco iOS operating system. The hotkeys and all that, totally different. So yeah, Control Z on a Cisco iOS. All right, that's just gonna exit you out of the actual. Yeah. So yeah. So again, so this is just covering. Well, we're just covering Cisco operating systems right now, not Linux. All right, my friend. Trust me, I understand. The hotkeys are different on both those operating systems. So that's it, my friend. Hope that clears that out. Hope that clears out for you, Raiden. All right, let's continue on. So what it's stating is we can disable Telnet, which you're gonna want to do, or we can disable SSH if you're not so smart. So we can disable Telnet from being able to be accessed, and that's so. Transport all, that's going to allow both Telnet and SSH. Transport none, you're going to pretty much tell it you ain't going to be able to log into this thing at all. And then if you just want Telnet, which you're crazy, or this would be the command right here that you're going to want to use is transport input SSH. And that's pretty much telling the switch that you just want access through SSH, and you don't want Telnet to be able to be accessed anymore. So the transport import SSH is the command you're going to want to pass through your device. All right. Let's keep it moving. To complete this section about SSH, the following configuration checklist details the steps for one method to configure a Cisco switch to support SSH using local usernames. SSH supports in the iOS can be configured in several ways. This checklist shows one simple way of configuring it. The process shows here ends with comments to configure local username support on the VTY lines as discussed early in the section. All right, so it's just going over the checklist. All right, configure your host name, IP, domain name, generating that RSA key. asking you for the modular size. Now the IP SSH version 2 command, that's just verifying that it's using SSH version 2. Okay. There is I believe there's another version 1 that's older, but I believe by default, at least the images that I'm going to be using tonight, by default they're using SSH version 2. Okay. All right. Transport import SSH. All right. So that's going to be the command that tells the device not to use anything else besides SSH on the VTY lines. Now you can still log into the console. It's not removing that, because remember, we're only in the we're on the VTY sub interface level. We're not in the console level. All right. You're still going to be able to access via the console. Okay. All right. The transport import all. Yep. That's just pretty much telling it you can still do both telnet and SSH. Okay. All right. Cisco routers often default to transport import none. So you must add the transport import line sub command to enable telnet or SSH. All right. So there's a little key thing that if you're configuring a router, by default, this command is enabled, and you need to establish the type of transport you want to enable. Okay. So you have to, while you're in that the VTY sub interface, you need to enable the type of transport you want to allow. All right. All right. 2 key commands give some information about the status of the SSH on the switch. First, the show IP SSH command lists the status information about the SSH server itself. The show SSH command then lists information about each SSH client currently connected into the switch. Example 6.6 shows a sample of each with user Weldon currently connected to the switch. So the show IP, it's just going to show you the version. Again, remember what I said. Oh, good looking out, Fuzzy. Thank you very much for that. Appreciate that. All right. And then the show IP SSH, again, just showing the version. All right. Show SSH, that's showing if somebody is actively logged in. So here we go. So it's showing it. It's showing the encryption, showing that the session is started, showing the user. All right. So it's showing that information right there. All right. Now, again, remember, we can't log into these devices remotely if we haven't established an IP address on that device. You can go through all these commands and you still won't be able to access this device remotely. Now you can still do it via the console. Again, remember, the console is physically, you're physically connecting to the console port on that device. All right, and you're using PuTTY to connect to that, as a emulator, so you can connect to that device. You cannot remote access this switch until we enable an IPv4 address to it. All right. So now that's what the next part of this section is going to into. To allow telnet or SSH access to the switch and allow other IP-based management protocols, for example, Simple Network Management Protocol (SNMP) to function as intended. The switch needs an IP address, as well as a few other related settings. The IP address has nothing to do with how the switch forwards frames. Now, remember, the switch is still the same logic. It's going to be working on layer 2 MAC addresses. It's not, even though you've assigned it an IPv4 address, which is layer 3, it still does not care about IP addresses. It cares about MAC addresses. All right. Remember, this is layer 2 switching. We haven't gone into layer 3 switching yet. Layer 3 gets into a little bit different things. Okay. Once we get to layer 3, we'll dive into what layer 3 switches do. Okay. It's a little bit more. All right. This next topic begins by explaining IPv4 settings needed on a switch, followed by the configuration. Note that although switches can be configured with an IPv4 address with commands similar to those shown in this chapter focuses solely on IPv4. All right, we're not going to get into IPv6 just yet. We're keeping it simple with IP version 4. All right, IPv6, a whole different animal. Okay, gets it's going to make this more complicated as we explain. And so I'm really glad that it's going to be sticking with IPv4. All right. Host and switch IP settings. A switch needs the same kind of IP setting as a PC with a single Ethernet interface. Per perspective, a PC has a CPU with the operating system running on the CPU. It has an Ethernet network interface, a NIC card. All right. The OS configuration includes an IP address associated with the NIC, either configured or learned dynamically with DHCP. I love me some DHCP. I can't live without me some DHCP. All right. A switch uses the same ideas, except that the switch needs to use a virtual NIC inside of the switch. So it uses a virtual NIC. All right. Like a PC, a switch has a real CPU running an operating system called iOS. All right, that's Cisco's proprietary operating system. All right, I know when you hear iOS, you might think Apple, but Cisco actually proprietary the name iOS, and that's what they call their operating systems. Okay, the switch obviously has a lot of Ethernet ports, but instead of assigning its management IP address to any of those ports, okay, the switch then uses a NIC-like concept called a switched virtual interface, SVI, switch virtual interface, or commonly a VLAN interface. So I know it's gonna be, so if you can wrap your mind, let's wrap our minds around this, just to kind of make a little bit of sense. Okay, so a switch, if you've seen a switch, you've got whatever, you got 10, 20, whatever amount of ports. These are ports, okay? Or interfaces, whatever. All right? You have, your fast Ethernet 0 dash whatever. Your gigabit Ethernet 0 dash, whatever. Okay. As long as we can understand what a switch kind of looks like, all right? So this is a switch. Instead of each port having an individual NIC, which is a network interface card, all right, what a switch is going to do is it has a VLAN, all right? Well, it has a concept of a VLAN. Now, what we can do with the concept of a VLAN is we can assign a particular VLAN to say we want these ports, all right, these ports right here, maybe 1 through whatever 6. Now, this is just high-level example, guys. Don't get too crazy on me out there, all right? So we're gonna say we want these particular ports to be on VLAN 1, all right? But we want these ports right here to be on VLAN 2. And then we want these last two to be VLAN 100, okay? And maybe the VLAN 100 is our management VLAN, all right, where we do some of our configurations, where we log in through SSH and whatnot, and so on and so forth. But what we're going to be able to do with these VLANs is each one of these VLANs, we can assign their own IP address to it, guys. That's what's so neat about this stuff. So on VLAN 2 is going to have its own IP address, okay? VLAN 100 is going to have its own IP address, all right? So these interfaces, they're not going to have their own separate IP addresses, all right? The VLAN, though, we can assign. That's where we're going to be able to assign the particular IP address to those, all right? But then we can group those ports, these interfaces. We can group these ports separately out and then assign them that particular VLAN, all right, that we want to be able to use, okay? Hope that kind of makes sense with you guys. And that's what this is kind of touching about, all right? All right. Take another sip of my water. All right. All right. So where are we at? So yeah, more commonly a VLAN interface that acts like a switch's own network interface card. Then the settings on the switch look something like the host with the switch configuration assign an IP address like IP. Yep. Cool. So here's just a quick snippet. So interface VLAN 1 IP address 192.168.1.8 255.255.255.0. All right. So again, you're just assigning. It's just like you would. It's the same concept like you would think about when you're assigning an IP address to a network card. Okay, but you're going to be assigning it to the VLAN, the virtual LAN, the virtual local area network. Okay, all right. Or like this said, the switch virtual interface, the SVI, switch virtual interface. Okay, all right. So let's move on. By using interface VLAN 1 for the IP configuration, the switch can then send and receive frames on any of the ports in VLAN 1. In a Cisco switch by default, all ports are assigned. So all ports by default, and we'll show that in one of the commands. All ports by default, all these ports would be assigned to VLAN 1 by default. So if we just went into interface VLAN 1 and assign it this address, all these ports right here would refer to VLAN 1 with this local IP address. Okay, all right. But again, this doesn't touch the logic of what this switch is still doing. This switch is still handling layer 2 logic with MAC addresses. Okay, all right. Okay. Again, I don't want to get too confusing on it. Okay. All right. And most network switches configure many VLANs, so the network engineer has a choice of where to configure the IP address. This is the management IP address. Does not have to be configured on VLAN 1, as configured on interface VLAN 1 command. Yep. Okay. A layer 2 Cisco VLAN switch needs only an IP address for management purposes. All right. However, you can choose any VLAN to which the switch connects. All right. The configuration then includes VLAN interface for the VLAN for that VLAN number and the appropriate IP address. So, I guess best practices is we'll get into all that later, but your native VLAN, like it's saying, is going to be VLAN 1, but you can still go into the switch and say, you want all these ports though to be assigned to VLAN 100, okay, and then give VLAN 100 whatever address, and then all these ports, like I said, would just be on VLAN 100 as your management plane. But again, that still doesn't affect how the switch is going to work. Okay. All right. For example, 667 shows a layer 2 switch with some physical ports in 2 different VLANs, VLAN 1, VLAN 2. The figure also shows the subnets used for those VLANs. The network engineer could choose either. So this is getting touch on subnets and whatnot. So you can see the subnet is 192.168.2. Now it's not giving us our subnet notation, so we don't particularly know where the actual network is residing. Okay, this network could be residing here, or it could be residing here. All right, we don't know anything yet, but once we get into subnetting and stuff like that, you'll understand what I'm talking about. Subnetting is a whole bag of awesomeness. We're gonna have some fun with subnetting. All right. Choose one VLAN of which to configure the switch's interface. Interface VLAN 1 with IP address 192.168.1.0. Interface VLAN 2. Yep. Okay. All right. Note that you should not try to use VLAN interface for which there are no physical ports assigned to the same lead VLAN. If you do, the VLAN interface will not reach an up state, and the switch will not have a physical ability to communicate. So it's stating that don't just create a random VLAN and start assigning it ports that have no device that has no physical connections to it, because that port won't come up. So even if you're trying, say you assigned an IP address to VLAN whatever and you gave it IP address whatever, but you actually didn't assign that VLAN to a port or interface that actually has any physical connections to it, that VLAN, no matter what, is not going to be on the up stage. So you're not going to be able to still connect to that VLAN, okay? All right, let's read the other note. Note, some Cisco switches can be configured to act as either layer 2 switches or layer 3 switches. When acting as a layer 2 switch, a switch forwards Ethernet frames as discussed in depth. Chapter 5, analyzing Ethernet LAN switching. Alternatively, a switch can also act as a multi-layer switch. When you hear multi-layer switch, you think layer 3, all right? Which means the switch can do both layer 2 switching and IP routing, all right? So layer 2, when you hear when you see the terminology L2 switch, layer 2, so think layer 2 MAC address, okay, frames. When you hear the terminology L3, layer 3, you just stepped up that ladder on the TCP or the OSI model, whatever you want to refer it as, all right, to layer 3, which is IP routing, which is packets, all right, IP packets. That's what a layer switch can do. It can handle IP routing, okay? And then as we progress, I'll show you we can set up DHCP. We can set up a layer 3 switch to act as a DHCP server too, and do all kinds of fun and neat stuff. All right. This chapter assumes all switches are layer 2. Again, it's only staying very low level. Well, very high level. I'll take that. Yeah, very high level, layer 2. Okay. All switches are layer 2. Chapter 17, IP routing in the local area network, discusses layer 3 switching in depth along with using multi-layer VLAN interfaces at the same time. So we'll get into trunking. We're going to get into multiple VLANs on a particular switch, inter-switch, inter-VLAN communication, switch it. We're about to take a serious deep dive into switching. The switching is, you can do so much with switches. Okay. Let's keep it moving. All right. Figure the IP address and mask on the VLAN interface allows the switch to send and receive IP packets with other hosts in the subnet that exist on that VLAN. However, the switch cannot communicate outside the local subnet without another configuration setting the default gateway. All right. The default gateway. The reason a switch needs a default gateway setting is the same reason that the host need a default gateway setting. Because if you don't have a default gateway assigned, the switch is not going to be able to know. Again, it goes back to like the same logic as the host. It's not going to be able to know where to send that packet so it can be routed to wherever it needs to go. All right. So, hold on one second. My baby wants to tell me she loves me. Let me show my baby some love real quick. Right, guys, let's get back into it. Just had to show the wife I love her. That's it. She's at work right now. All right. Figure 6.8 shows the idea in. Is the text on the screen a free resource? No. I have a subscription. To O'Reilly. O'Reilly Media. I pay for this subscription. I pay for the books, the physical books. I pay for all this stuff. What I'm doing is I'm studying. I'm doing a self-study for my own exam, all right? And I'm going through all of this as we're going along here. So I pay for all this stuff. So, yeah, that's it. All right. Figure 6.8 shows the idea in the case. The switch on the right will use IP address 192.168.1.200 as configured on interface VLAN 1. However, to communicate with a host A on the far left on the figure, the switch must use router R1, the default gateway, for the IP packet to the host A. To make that work, the switch needs to configure default gateway settings pointing to R1 IP address 192.168.1.1. In this case, note that the switch and routers both use the same IP, same mask, 255.255.255.0. That's a super friendly way to concurrently code. It's nice when networking stuff. Yeah. Raiden, so what I'm going to be diving into next, so I don't want to get too far off topic, but just to share with you, the next step from here is I'm going to be diving into my DevNet certification. And in the DevNet certification exam, and I'm going to be setting up a whole study lab for DevNet certification next. That's heavily revolved around Python, Bash scripting, Ansible, Docker, taking all of that programming and using that to automate networking and it's obviously it's the next it's the future. So DevNet, DevOps, I honestly feel I'm hopefully to become a DevOps evangelist, because I feel as though that's the future of everything. Pile single binary which blows away Java, and it's an easy way. Yeah. Oh yeah. I mean, Python coding in Python itself is so much. I guess it's easier to learn, and it's more for me. It's been a little bit more readable, a little bit more easy to understand. To get started off with. Oh yeah, man! If you stick around, Raiden, we're going to be diving into DevNet operations and how to incorporate Python, incorporate Bash scripting, incorporate Ansible and YAML. Making Ansible playbooks and using heavily revolved around Linux and stuff like that. It requires users to have a which sucks. Java, like Java jar, links deleted. Yeah, Java's. I haven't spent too much time messing with too much JavaScript, but I have spent a fair amount of time with Python. But all right, let's continue on here. So again, in this example, it's just communicating what you need. You need that default gateway assigned for network communications to work. All right, and this is just configuring an IPv4 address on a switch. Now again, we're gonna lab this up, so I'm not gonna spend too much time on just what it's going off here. So we want to get into interface VLAN 1. We're gonna assign that address. We're gonna give it the no shutdown command. Now the no shutdown command is a very important command, because that's what brings that actual, that quote unquote VLAN interface. Even though it's a virtual interface, you still need it. Even though again, it's not physical ports, it's virtual. All right, you still need it to give it that no shut command, which brings that VLAN up. Okay, so then it can actually be up. All right. Now remember, the IP default command, we're gonna step out of we need to come back to the global configuration mode. We need to exit out of the interface VLAN subcommand mode, and we need to go back into global configuration mode, and that's when we're gonna give it the IP default gateway 192.168. Yada yada yada, and give it the default gateway mask. Okay. Option, his IP name server. So if you want to give it the server name, that's cool. We really don't have to get into all that. But here's a little code snippet. Again, you're in enable mode. He moves from enable mode to configuration terminal mode. And from configuration terminal mode, he went into VLAN interface mode. All right. and then he performed the IP address, gave it the no shut. All right, here's now these were the messages that I said, if you give it the synchronous command, these messages will wait till after you're done punching in your commands. But if not, as you're doing these commands, these messages will come up automatically. Okay. All right. He exits out of the VLAN interface mode and goes back into global configuration mode, and that's when you assign the IP default gateway, yada yada yada. Okay. All right. On a side note, this example shows a particular important common command, the no shut. Yep, the no shut command to administratively enable an interface on a switch uses the no shut interface command. To disable the interface, you use the shut command. This command can be used on a physical Ethernet interface, so you can physically. So again, we can go into each and every one of these ports or interfaces and give it the shutdown command and say, I don't want this port to be used no more. All right, but that same logic works virtually on these VLANs. Okay, it works. It's acting the same. It's performing the same thing. Okay, so if say we had just these ports right here, say we had these, these ports right here assigned to VLAN 1 here, and we gave VLAN 1 the shutdown command, because we have all these VLANs, all these interfaces, all these ports assigned to that, it'll actually shut down all those ports. All right, shut down, boop, boop, good night. All right, so it's kind of powerful. All right, we all know use languages as a tool to certain problems, so I'm not saying to use Go for all tasks, but badass. I really haven't messed with too much Go. I have been seeing some because of my subscription too. I take a lot of live courses with a lot of these people that in the field and do a lot of this stuff heavily. My interest with Go and stuff like that, will come. I'll get into all that as I progress. I'm trying, I'm starting fundamentally, working up to DevNet. From DevNet, obviously that touches a lot of programmability. And then, we'll get into AI and all that stuff. I eventually want to set up my own AI to configure actual network devices. I want to get to the point where I can create an AI to actually manage network devices. Obviously through the process of making, having an AI, inside of an actual network, and start making decisions on its own, making mistakes, learning from those mistakes, and so on and so forth. Go is just modern C. It's garbage. It's garbage collected. So it's like Python for C. I love that. All right. So we've talked about the no shutdown command. Configuring a switch to learn its IP address through DHCP. Now I love DHCP. I love setting up DHCP servers. DHCP servers make life easier within your network. They honestly do. Doing things statically, you can make, you can fat finger things, you can make problems for yourself. Things might not work correctly, and so on and so forth. So I've already invested some time with, learning about DHCP, applying DHCP. I have a lab over here in CML that I have. I created over here a Linux box, a Linux machine that acts as a DHCP server for this network right here. So this network right here is being supplied DHCP by this server over here. But let me grab another color. But this router right here is acting as this network's DHCP. All right. So DHCP is pretty neat and can do some pretty fun stuff once you take the deep dive. and in in rating over here, I don't know if you've ever used Cisco Model Lab. I use Cisco Model Lab heavily, and no, I'm studying for my CCNA rating. That's what I'm. That's again. I'm going along with everybody else who's watching this with me today, man. I'm studying all for it. I started studying in about August time frame. I know it's December now, so I've been studying for a couple of months now. But I wanted to just start back from the very beginning and hammer it totally in my head. When I take this exam, I want to know for sure I know every single answer. Yeah, Packet Tracer is awesome. Dude, Packet Tracer, I tell everybody, download Packet Tracer. You can do everything for your CCNA, even some, you can do, so Packet Tracer is a simulator. Obviously, you probably already know that. But there is a Python. I don't know which version it is. It's been a while since I really, but there is some Python on in that in those PC images or whatever you want to call them, simulators in Packet Tracer, and you can actually do some Python coding and do some automation within Packet Tracer. You're not going to be able to get too far with it. Like you can't do Ansible stuff and stuff like that because obviously you can't connect Packet Tracer to the big internet because it's a simulator and whatnot. But Packet Tracer is amazing. I love Packet Tracer. I still use Packet Tracer for the simple fact of when we start getting into like the Wi-Fi stuff. With it being a simulator, that's where it has the advantage over like GNS3 and CML. Because there's no real way to virtualize Wi-Fi because you're actually, at that point, you're just really using Wi-Fi and you'll just be messing about in your own house or your own lab. All right, here's some configuration checklist for the VLAN setup. Again, we're going to be labbing this very shortly, guys. We're almost done with this chapter, so stick with me. Verifying the switch is verifying the IPv4 on the switch. Show the run, the show run configuration command, the show interface VLAN command, show DHCP lease. That's just showing you that you obtained yada yada address from the DHCP server. Here's the subnet, the default gateway. The VLAN is up. So miscellaneous settings useful in lab. Need some goals, not sure what I want to study next. Yeah, figure out, I guess, figure out what your next level in your job is. I don't know if you work in IT or whatnot yet, but figure out what would make you more profitable to your job. Would that be becoming, Red Hat certified Linux administrator? That's a serious certification. That's one I'll be looking at next. Is it security? Is it pen testing? Is it there's so much to go after. What I'm trying to do is I'm aiming my direction and network programmability. I want the direction of network programmability. So I need fundamentals of networks. From fundamentals, then I need some programmability background to understand DevNets, DevOps, CI/CD, all that stuff. So that's the direction that I'm aiming towards, and that's where I'm aiming my goals towards. Yeah, me myself either. I'm by trade, I'm a heavy equipment operator. I operate dozers and backhoes and front end loaders. That's what I was doing before I jumped into this. And then I had an injury that pretty much put me out I wasn't able to walk for quite some time, gained my ability to walk again. But during that whole time of recovery, I ended up stumbling upon a David Bumble. He's great. David Bumble is great, by the way. I ended up stumbling on one of his YouTube videos. He got me super interested in CCNA, network fundamentals. And then from there, man, it was like a fire was lit under my butt. And from there, I've just been taking the deep dive into all this stuff. All right, let's get back in. Thank you for reading the bio, man. I appreciate that, brother or sister. Let's get back into things. The last short section of this chapter touches on a couple commands that can be useful for practicing in lab. History buffer commands. So this is just showing some of the show commands. The show commands, you'll always relying on these show commands. Repeating to use these show commands helps. It helps. The log synchronous. This is just some miscellaneous stuff. Obviously, the log synchronous, again, that helps with the messages so they don't just pop up as you're going along. And the no IP domain name lookup. So that helps you, again, if you're going along the command line interface, you misspelled something, you press enter by accident, it's going to try to look up that domain name if you put in the no IP domain name command. Though, it'll just tell you, you misspelled your command. Okay? That's it. Yep. Cool. So a chapter in review, some key topics to remember. So, example of a configuration password, log security, no username, SSH configuration commands with related username. All right. So key terms should know. Come on. Telnet, SSH, local username, AAA server, enable mode, default gateway, VLAN interface, history buffer, DNS, name resolution, log messages. Okay. Now that is going to complete our actual review of this chapter. Now we're going to move over to Cisco Modeling Lab. We're going to create a lab from beginning to creating these usernames, logins, and whatnot. And here's just some useful commands. These are actual real commands to just review as we're going to be going along. All right. Yep. Cool. All right, guys. So that finishes the actual chapter review. Now let's get over to CML. All right. Let's jump over to our little lab we got going on here, and I'm gonna switch over to my other camera so I can take a seat finally. And we're gonna get started in the lab. All right. Yeah. Well, hello, everybody. A little dark. Where'd my light go? Mr. Light, which way did you go? Put my light on real quick, guys. Got a second, I'll power up. Hello. Woo! Alright. Let's get started! Alright. So, what are we doing today? We are doing some... Actually, let's make a new lab. Should drop it down here. I'm going to grab a switchy switch. Grab a PC. And... Hey, we'll grab a router too. I'll configure DHCP real quick on this router so you guys can see DHCP working. Zoom in real quick. It's up a little bit so you guys can see the command line pretty well. Make some connections. Alright, let's fire these up. and I'll leave the PC off for now. All right. So, again, what we're going to do is we're going to be creating we're going to be setting up password first, so we can log in. We can log in via Telnet. All right, we're just going to go through exactly how the chapter was broken down. All right, and then we'll set up SSH. All right, we'll set up some VLAN. We'll set up a VLAN. All right. We'll do VLAN 1. All right. Ooh, my spelling's atrocious today. All right. So what I'll kind of do first is I'm gonna jump. I'll probably get on this once this router boots up. I'll set up a quick DHCP server on it. That way, when we get to the point on DHCP, it'll be faster to enable DHCP on that switch. But we'll statically assign the VLAN's IP address first, and then we'll remove that, and then we'll allow DHCP to do the DHCP job. But DHCP does everything awesome. Everything is awesome. Oh, that's where we'll go. You know what, guys? If you don't mind, just give me like 2 seconds. I'm just gonna run real quick. I'm gonna grab some more water while this switch is firing up. I'll be right back. I apologize for that. Just give me 1 second, guys. All right, I'm back. My little monkeys are all pumped up because Rocket League, I guess, just dropped their season 2 update, whatever. So they're all happy. All right, just needed some water. Get thirsty. All right, all right, what did I say? I was gonna set up DHCP first. No. This thing. Get you up. So we're gonna move. All right. Let's get into that. Host name. SW1. All right. Get through its thing yet? All right. So we're gonna walk step by step right through the actual commands here of configuring switch security. All right. So I'm gonna log into console 0. Set up password. We're going to give it the password of Cisco. All right. And log in. Exit. Password. We're gonna give that. I'm gonna say love. And exit. So what we've done is we set up the line console password as Cisco, and then what we did now is we went into the line BTY line. Okay, that'll be telnet. All right, and we set the again just the password as love. I gotta find this guy. The only way I'm gonna be able to, I guess, demonstrate that. Yeah. So let's go into interface 0.1. Give you a quick IP address. 1 5 5 5 0 shut exit DHCP pool. We're gonna say net 1 10.0.0.0 255.255.255.0 pool default 10.0.0.1. We don't need, really don't need anything else on that. We don't need, because we're not going to be connecting out to the internet or anything like that in this lab. So we don't need to set up DNS or anything else like that. So there. We'll give it a, we're going to give this a DHCP exclude address 10.0.0.100. So 1 to 10.0. That pretty much, let's just write that configuration real quick in there. And this is up now. They already got an address. Sudo if down a sudo up dash I should configure them in the range I've already configured to. Whatever. No. And 10.0.0.1. Cool. So we got that set up. Oh, that's working. DHCP is working. I'll come over here, and what we'll do next is on interface. I'm gonna say IP. Do I have my own network and equipment, or have a fancy home lab? No, I don't. I don't have anything physically. Everything I have is virtual. I have everything virtualized. What I do, Raiden, if you've ever come across VM, like say VirtualBox, what I use is I use VMware Workstation Pro as a layer one, as my layer two hypervisor. So that's sitting on my host. That's what's sitting right here. All right. So I use VMware Workstation Pro, and then on VMware Workstation Pro, let me X this out. I use EXI as a layer one server hypervisor, and then that's where I boot up, multiple VMs. It's like Proxmox, if you've ever come across Proxmox, because I can, make virtual switches and everything else from there. I think to learn, it's probably best to own your own cheap. Yeah, and it is. You're exactly right. I'm not gonna take. How's this? I won't take away learning, actually using physical stuff, as being the best way, because at the end of the day, you're gonna be, having to touch physical stuff, plugging in cables, doing this, doing that. Because of the financial situation, I won't get into all that. The financial situation I'm in and everything else. I've been very fortunate though to have this, and utilize this stuff and not having to get into the physical stuff. But the physical stuff, I'm gonna get into all that, as things get better and whatnot, and setting up an actual lab. I'll even do a stream setting up an actual physical lab in the future, though. But for now, with it all being virtualized and stuff like that, this is the actual real. This is using real images. None of this stuff. So this is an emulator, not a simulator. Just like if you've ever used GNS3, it's the same thing. I'm using. This is actual. If you see down here, this is actual real CPU usage. All right, real memory, real disk space, and stuff like that. Yeah, decent switch probably costs $500. Ain't got $500. Not even. I don't have nothing right now. But yeah. That will come most definitely, Raiden. Let me just statically assign this an IP address real quick. 0 dot. We're gonna say. Shut. Okay. All right. Boop, boop, boop. All right. Ping the router. Let's just make sure we can ping the PC. And we can ping the PC. Okay. Very good. All right. Just save that configuration real quick. All right, let's go over to the PC now. Telnet 10.0.10.0.0.3. All right, we gave it the telnet password was love, right? All right, so now we've just actually logged into our switch. Now remember, we haven't given it the enable password. Is it still looking? So did I give it the enable password already? Oh, so it used the console password as the to get there. So we've already moved into our next branch of management, so we can go right into the configuration mode now, and now we're in configuration mode. So we're on the PC, all right, and we've logged into the switch. Now I'm gonna capture the packets on this, all right. We'll log out, and we'll do a packet capture too, all right. So let's exit. We'll end. All right. And exit. All right. So we're back. We're back on our PC. All right. Remember, we'll do an IP address. All right. We're back on the PC. So let's come over here. Let's capture some packets, and I'm going to show you. What the reasoning why Telnet is such is no good. Start our packet capture. Let's Telnet back over. All right. Love. All right. We'll move into that. That password. All right. We'll move into configuration mode. Come back over here now. And we'll look at our packets. All right. So we've started capturing our packets. Let me make this a little bit bigger so you guys can see it a little bit better. Place this up. Place this down. All right. So let's get to our first Telnet. And let's take a look at what we got. No, it's not telling me too much. That's the first one. All right, so this is when it starts telling us some stuff. So look at this, guys. Clear text. Remember, clear text, Telnet. 2, not much there. Woo! Here's my user. Let's look and see. Let's give it now. Let's look. Let's go to the next one now. It's going to start telling us some good stuff here soon. So there's the first. So there's the L. There's the first one. There's our L. There's our O. There's our B. And there's our E. So there we go. So we just over Telnet, it clear texted us our whole password. And there's more data. Some more data. All right. And then here's our switch now. We're in SW1. And then we moved into enable mode, EN, right, yep. EN, so we moved into enable mode. And now we get to the point where we're gonna be prompted another password to move into enable mode. And here we go, here's our C. And our I, oh, and we didn't capture, that was all the 50 packets that we captured. So, as you can tell, and that this is the reason and why Telnet is insecure. It sends everything as clear text through the wire. All right, so take a sip of my water. All right, we'll go back over. Where am I at? PC. Let me just exit PC now. Back over switch. And here, there's some information right here. So it showed that over the console, over the VTY 0 lines, 10.0.2, the IP address 10.0.0.2, which is this desktop right here, logged in via from the console by VTY. All right. Now let's set up SSH on this on the switch here. All right. Let's get this party started. All right. Where are we? Let's exit out of this. IP name. IP domain name. We're gonna give it Cisco.com. Sure. All right. Let's do the crypto. There. Oh, good. This one doesn't have that issue like the router did. So, say this. All right. So we've just created a crypto key. Let's just make sure it's using version 2. All right, now let's move into the line. PTY again, 0-15. What we're gonna say now is we're gonna remove telnet. We're gonna enable telnet. So transport input SSH. Okay. All right. Let me just write this real quick. All right. Now let's come over to our host and we're gonna try to telnet back into it. All right. So there we go. So telnet cannot connect to remote host 10.0.3 because we just enable it. Okay. So it's SSH now. All right. Let me read this real quick. Unable to negotiate port 22 not matching exchange key method found. This offers to find. Oh, I know why. S1 at 10.0.0.3. Ah. How much RAM? More than 60, more like 64, 128. Oh, I got my PC. I got 48 gigs of RAM on my PC, and I give Cisco Modeling Lab, I believe, like 16 gigs just on its own. So I got Cisco Modeling Lab running in just as 16 gigs, which most people would run on their PCs themselves. Let me just troubleshoot this real quick. Hold on, guys. Hold on, real quick. Hold on, my monkeys were getting crazy on me. Alright. Yeah. No, SSH version 2 server connection running. Okay, cool. So let's do. Give me 1 second, guys. Just shoot this real quick. Let me just make a user real quick thing. User name. Bob. Password. We're gonna just give it a simple password. We're gonna say cat. And SSH. Oh. Line BTY 0215. Log in. Local. Say no pass. What's that? Some key exchange. You're giving me a hard time, SSH. You're giving me a hard time. Create a crypto key. Yep. Alright, let me just do a run real quick. Take a look at configuration, see what's picking me up here. Somewhere along the lines, I got a hiccup. I got a host name. Yep, that's one. Cool. Password. Yep. VLAN. SSH servers up. Transport SSH, that's configured correctly. Yep. We got our domain name. Yep. Cisco. You know what? Let me just try this. Cisco 3. Doesn't like that. Sorry. Why are you giving me such a hard time tonight, SSH? Troubleshooting, gotta love the troubleshooting. It's all about troubleshooting. That's where I find I learn the most at when I troubleshoot things. Always found I learn more doing that. This what I'm getting messed up on? Let's get out of there. Let's do Bob again. Say privilege 15 secret. Both user and password. User, please choose another. SSH. Wall. Ooh. It's not like me to SSH. Nope. Oh, stop it. This SSH is broken on this thing again, like it was broken before. S1. It should just go off at S1. I'm not getting why it's not allowing this. Enable, negotiate with 10.3, port 22, not matching key exchange. Their offers differ. Exchange. Why are you messing with me? Mr. Switch? Mr. Switch, why are you messing with me? Yeah, I walked through that whole configuration the correct way. It's just not working now. Done this 1,000 times and now it's not working. Hold on. We'll figure this out. Got a host name, IP name, yep. Created a crypto key, yep. Transport, yep. All right. Where is it going wrong? Where are you getting wrong, man? If we already got the host name as S31, sure. Already been through all that. We created the IP domain name. Like that. Bob again. 3 doesn't either. Alright, let's trouble. What are you going wrong? Users in there, of course there isn't. We've set that. Let me just go back into configuration mode again. BTY 0 to 15. Warning. Pretty sure I've already configured that. You know what I do? Transport, import all, just to see if stick it into it, telnet or something. Bob's password is cat. Enable. Here. That still works. Okay. Telnet is still working. Stage should be switched up to 1. It's still just benign. 3. Huh, SSH does not like me. All right. Bob. No, are you tried Bob yet? No. Huh. Huh. Meh, meh, meh. Meh, you see here? Meh. I'm about to wipe you. Start you all over again. What happened to you? What happened? What happened? You're gonna get shut down, man. You're gonna get shut down. Let me remove these links real quick. Sometimes these things get goofy. That's fine. No big deal. No big deal. Just fire it up. You, on the other hand, you are going to get shut. Well, you're already shut down. See you later, buddy. Sometimes these things break. I don't know. Like I said, I already had issues with the router trying to the router's missing the whole crypto key command itself. I'll show you. Darn. Global configuration mode. The crypto key command is actually totally missing from crypto spell. So it's actually missing. It should already be picking that up. So that right there is already showing, you know, that tells you that there's already a couple issues with the actual image itself. So crypto key generate, it should already be completing that. Isn't. So that whole command, like I said, I've already run into some hiccups with some things. So I'm not too surprised if it's gonna give me a hard time about this. Like I said, that's why I was gonna go back to GNS3 because the image, like I said, the images that I got on GNS3, I haven't found any issues with those images, but the images I have up on CML, I've already found plenty of bugs and issues and all the other fun stuff. So I wasn't really surprised. I'm not surprised. How's that? That this is giving me a hard time connecting via SSH. But what I'll do is I'll start a total fresh one and we'll go from just freshly setting up SSH from start to finish on this to see if it's me or if it's the crazy switch itself. Again, it shouldn't have gave us a problem right there when we connected it, but see it did. Are we up there, Betsy? Brand new switch again. No, not then. So there you go. So there's the no IP domain lookup. So when you misspell something, it's gonna look for it's gonna try to translate that with the domain server, and obviously there isn't one. Oh yeah. No. Come on. Oh, Betsy. All right. All right, we're gonna start from the beginning. From the beginning. All right. Here we go. Hosting. SW1. Cool. IP. Domain. Domain name. I'm gonna give it Cisco.com. Cool. We're gonna do crypto. Crypto key. Generate. RSA. I'm gonna give it 1024, like in that book. Cool. Go to the next page. I'm gonna say IP, SSH, version 2. Cool. Go down to line. BTY 015. We're gonna say log in local. Exit. Okay. We're gonna from there we're gonna say username. We're gonna say Bob. Password. Give it Cisco. Cool. All right. Now we gotta go back into interface. VLAN. Now I'm gonna do DHCP, DHCP, address, DHCP. Got. All right. Now it should actually get a DHCP, an IP address via DHCP. And that goes back to the when we previously, so there you go right there. So it just got an IP address via DHCP. So whatever, we had to kick that other switch out of my network. Get out of here, you dumb switch, you. Whatever. So I was able to show how DHCP works. So DHCP assigned that address to our switch's VLAN. Okay. All right. Yeah, so we've already got that. And let me just do right real quick. Do right. All right. Let's try this again. SSH. All right. What's gonna say? That's fine. That was 10. It's 101 now, right? SSH. Why are you giving me a hard time? Bob. 10, 0, 0, 1, 1. You're broken. You are broken. I swear this is broken now. See. Yeah, now tell that. Bob. Give it. I'm gonna give the password. Is it that? What the hell? Give the password. Oh, it's this one. Tell that's working. So need to enable the secret. Exit. Enable secret. Enable secret mode. Okay. Confirmed. Telnet is working. Very good. Okay. This now. Again, let's do SSH again. Now this isn't the right way to do it, but okay, cool. Curious thing. Such a curious thing. Yeah, I think this might be a. All right, let me boot up GNS3 real quick. Hold on. Just switch over to this real quick, just so I can log into my EXXI server real fast. Hold on. Back. Just logging into EXXI real quick. Let me shut down the lab. That down. I got it here. Let me just power GNS3 on. GNS3 up real quick. Only caveat to use it is both laptop and desktop have to have the same directory server. Oh, you wrote a bash script to copy files from a desktop to laptop. Only caveat is it both laptop and desktop have the same directory structure. Yeah. Bash scripting is fun. I love bash scripting. I actually took a course. What was it, last week with Xander Von Blunt, who's a he writes a lot of the cert books for the Red Hat Enterprise Linux course. It's a one-liner, but it has it's basically a 1 or 2 liner, but it has 43 lines. Yeah, let me I'll fire up my little Linux lab too. Let me kill Cisco Modern Lab real quick. Let me shut that down. That's booted. Let's What's the IP address on that again? 192.207. Cool. HTTP. Yeah. Fire up. Fire it up. Fire it up. That a second. Fire up. Let this come up. I think I have a couple of bash scripts on this image real quick we can take a look at. I think I do. I think I do. Yeah, so we can actually open up the consoles to it. Booting. It's booting. Viva la boot. Viva la boot. I'm on, baby. You up. And open you up in a new tab. You fired up. This is why, again, I love using all of this stuff off at EXXI, because I can open up everything off of a web browser. Terminal. Let's see. What do we got? What do we got? What do we got? Yeah. There's a simple bash script. Oh, that's the one I wrote for the Python program. Which one was it? Which Python program was it? Was it the? Oh, let's just go back. Let's see. It's the device.py. That even still there? Yeah, it's right there. So let's. So this was just a simple Python program, just creating classes and whatnot, whatever. And it just comes up with that. Boom! I love bash script. So much fun. So much fun to write a quick and easy bash script. We'll make another one. Yeah, we'll say bash. Bash whatever. Bash something. Bash. Why am I doing too many things at once, I think. Now I'm drawing blanks everywhere. Play echo. Hello. Hello, everyone. There's a simple and quick bash script. This is a Python script. Did you program call bash, or did Python call any Linux programs? Oh, so that other one. So, the device here. So device router. It's calling in. So it's first it's echoing. This gets info about your router, but then I have a Python. Then it CDs into the root directory, and then it's calling Python 3.8, and then it's opening Python 3. I have Python 3.8 opening device pi, and then device pi. I just have device pi. I just created a class router, gave it some identifying, attributes, and then I assigned it to router one, gave it the class, and then I just have it printing the description that I created here under get the script self, and then that's why you see all that when I call it. That's when you get this. This is the echo that the bash is doing, and then this is the Python program, and what the Python program is creating. Yeah, it's super basic. Yeah, my knowledge is so basic too, man. So I feel you. Let's see how far we get. Everything's still moving up. Come on, Betsy, hurry up. Yeah, I love Python, man. Python's so fun. Python, bash scripting, all that stuff is fun, man. I love doing all that stuff. This stuff is so neat. I'm so glad that I stumbled upon all this stuff and started really messing about with it. Just because I've learned, just in the short time I've learned so much. And there's so much I need to learn. I made a JavaScript StarCraft 2 tool and had to learn Python basic because I had Python dependency. My Java code calls Python code. Python code returns data. I handled the Java then I just learned Go and the entire thing. Do the entire thing when I right. That's awesome, man. Switches up. And the router's up. All right, cool. All right, so let's jump to the router real quick. Configuration mode. Gigabit. The address. 10.1. I'll try to blast this out real quick. Shut. Exit. Right on. IP, DHCP. Cool. Net-1. Yeah. 0/4. default. Exit. DHCP. Exclude 10.0.0.1. 10.0.0. You know what? I'm not even gonna care. You can do that. You can assign. I'm gonna let you do whatever you want, DHCP. Get me some addresses. Okay. This thing probably got an IP address. Real quick. Verify. Do you not get an IP address? No? DHCP. Let's go back to the switch now. And let's go into interface. One. I'm on, Betsy. There we go. IP address. DHCP. Address. DHCP. That's the weirdest thing I've ever seen. All right, now that gets my IP address. I don't know if it might. It might not. If it doesn't, I'll static one. All right, well, let's do that again. Let's see if it works on GNS3 now. All right. What's the name? What's the name? SW1. IP. Name. Name. I'm gonna give you a lab dot. Alright, then we're gonna do crypto. E. Generate. Say. This line here. Now we're gonna do IP SSH version 2. Okay. Right, now let's exit. Not exit. Fine. 2 0 15. Say okay. I'm just gonna say login. Exit. Cool. Secret. Let's see if we got in. Let's see if we actually got an IP address now. Pretty sure we did, but let's just make sure we did. Come on, hurry up. Take 10 years to write this configuration. Come on. That's one thing I forgot to do. I forgot to bump up the CPUs and the RAM on GNS3. That's why it's probably taking so long. So DHQs. I just want to see it. It did not get an IP address, did it? That's an issue. That is an issue. Well, that works. H. Fine computer. Hmm. This is normally not that difficult. Yeah, I'm sorry you're having a hard time reading the text. I'm on, Betty. Let me hold on. I'll have to. What is it? Hannah Law. Yeah, we're nearing the final bit of this lab, and I'm running into all kinds of issues right now with it. I've already bounced back and forth to a couple programs. I just actually booted this up. It's not like a regular thing. I could probably open it up on a. You know what I could do? Zoom, maybe. Yeah. There you go, Hannah. I'm breaking everything now. It's freaking out on me. What is it doing? I lost it. Hold on. I try to get it back here. Right, that's working. Lost my router. Hold on. Open up another console of that. Yeah, I'll make it easy. I'll just open up a whole console to it and zoom in that way. I'll mix this all up. This will be the PC. This is GNS3. Whoa, let's. There we go. Alright. So, what was I? Oh, I'm about to explode this thingy because it's giving me such a hard time with everything. So, Joe VLAN. So VLAN. Oh. I set the feeling, right? Pretty sure I did. Like you said, that's done. Again, is it not? Why is it giving me such a hard time with SSH tonight? I mean, tell that. I don't know. Works perfect. That is enable mode. This. Check. Wham bam, thank you, man. No, elephant. No. Why are you giving such a hard time to SSH? I don't understand it. So we're using, yeah, I think you've heard me. So we're using, this is GNS3 right here. Yeah. Ooh, yeah. Fix that afterwards. SSH. Switch. 10.0.0.
0.3. That hates me. Did it even send in messages to the switch that it's trying to log in? No, it's not. U-L. Ah! Oh! Oh, praise the heavens! Oh, praise the heavens! We did it! Oh, we did it! I'm gonna need a drink after this one, guys. Woo! What a relief! Epic. Epic, Joe. Epic. Epic, epic, epic. Oh, wait. It closed on us. Ah! You damn jerk. Ah! I forgot. I didn't notice that. Ah, you son of a bitch. You bastard. Haha, now it's giving us a hard time about that password. Secret. Enable secret. I'm gonna say. Love cats. If I could spell. Come on, Betsy. Put me up some configuration. Something. Give me something. Got my enable secret password. Sweet. Host name. Got my domain name. Got 1,000 interfaces. Got my IP address set. Cool. Got my SSH server. SSH is running version 2. Very good. So, we got that in. I was given such a hard time. SSH does not like me today. Got the password set at low. Alright. We got transport all, so we can log in telnet and everything else, and we'll do telnet again. In there like swimwear. Or okay. What am I? Cool. I don't want telnet. I want to connect through SSH. Password should be the same thing. Should be. And it's just closing it out. This is a curious thing, guys. And this crazy thing doesn't have any commands. Ooh. I mean, let's even just try to ping that. Either. Ping the VLAN. So you're registering that I was just in there via telnet, but you're not registering anything. SSH. Huh. What is going on here? Let me go back to the switch then. We're in configuration mode. We'll set up a user. I'll user Bob. User Bob will give privilege. Code 15. We'll give him a secret. Password. Dog. Okay. Go back into BTY 015. We'll do login. Login local now. I'll erase that previous password. Alright. We'll keep transportation as everything. Now let's telnet. 10.0.0.3. Now it's going to ask us for a user, which is Bob. Bob likes dogs. Okay. Now we're in. Enable mode. Well, we're already in enable mode. Oh yeah. So this is why doing that that command, the IP domain, that no IP domain lookup is so awesome, because it'll prevent this from happening. And I just keep forgetting to put that in my global configuration. Alright. Where am I? I'm on the Alright. Let's do SSH. What is it doing? It's not even. It's like it's broken. Because it should be asking me for a username now. No matter what, it should be asking me for a username. So I wonder. if somewhere along the lines on the switch that SSH is broken. Because it should be prompting for a user. Because I just set a user. I removed. I was doing something wrong. Yeah, I just put in all 3 of the passwords I said. Love, Cisco, and dog. I remember I just deleted love. Cisco was the enable secret password. Oh wait, cat was it. But either way, it should be asking me for a user, not password. Really makes me think if this is broken. Huh. I'm gonna have to dive into this a little bit more, guys. What I will do, and I will promise you, is I will continue to work on this. But what is it? 9 o'clock. I gotta get my kiddos to bed. Guys, I want to thank you all for joining me, and I am so sorry that I'm running into so many technical issues all of a sudden here. But this should be working. I don't understand why it's not working. We went through every single step along the way. Like I said, I've run into issues with these images doing some goofy stuff. So, guys, I want to thank every single one of you guys for joining me. Stay tuned tomorrow. We'll be back here. Again, tomorrow like I said, tomorrow morning I'll dive into here and I'll play around with it some more, and I'll ask some more questions too on the little community forum to see if anybody else has ran into these issues with these images. If they have, then it's probably just the image. But if not, it could just be me. Who knows? But tomorrow, though, the guys will be jumping into Chapter 7 of the CCNA 200-301 exam. All right, and that is configure and verifying switch interface. Okay, so just a quick review. That's explain the role and functions of network components, L2 and L3 switches, describe switching concepts. So it's like a quick, so this gets into speed and duplex and description on the actual interfaces, multiple interface and interface range commands, shutdown commands, removing configuration and no commands, auto negotiation. What else? Let's get into speed and duplex. Yep. So pretty much it just gets into manipulating the speed and duplex on the separate interfaces. The some show MAC address commands and whatnot, and that will actually finish part 2 of the CCNA 200-300- exam cert, and then we'll be. I'm still on the fence with how I want to do Friday stream. I kind of want to do one big overview of part 1 and part 2, just to make sure for myself too, I've really nailed down all these topics and figure this out, why this isn't working. I owe you guys this now. I owe you guys this, and I owe you guys an answer why either I couldn't get it to work or why it isn't working itself. So no matter what, guys, I owe you guys on SSH, and I will figure that out. So don't let me, when you guys join me tomorrow, say, Joe, you owe us SSH. All right. And I promise we'll get a lab up and running with SSH working. Okay. No matter if I gotta rip
rip the virtual threads out of my computer. I'm gonna get it to work. But then again, we'll dive into that Friday. Still, again, I'm still on the fence for Friday, but I'm thinking we might do a whole part 1, part 2 review. But again, guys, join me tomorrow, 5 o'clock Eastern Standard Time. We'll be jumping on the live stream, and yeah, guys, from my house to yours. Thank you very much, guys. I love every single one of you guys. Thank you for all the love tonight. Raiden, Fuzzy, everybody who's on, who's been chatting it up. Thank you, guys. See you again tomorrow, everybody. Have a good night, everybody. Mwah!